Find the velocity, speed and acceleration of a particle given that at time t seconds. We've got two different situations here for the position vector r. And sometimes x is used for the position vector, sometimes r, sometimes s. You must be aware of the different notations. So r is the position vector, or you might call it the displacement. We're going to differentiate once to find velocity, twice to find acceleration, and we mustn't forget to also find the speed as well, because that's what the question wants. So for part A, differentiate once, and we get velocity. Now I've used a slightly different notation here, r dot. R is a vector, so it needs underlining. The dot means we have differentiated with respect to time. So not x, not y, not any other letter, but time, only time. So a dot on the top of a letter in this context represents a differentiation with respect to time. You're welcome to use that notation in your maths A level. So there's the velocity. Before I differentiate again, I'm going to do the speed next. So velocity is a vector, but speed is a scalar. We learn how to find the magnitude of a vector in pure maths. It's a bit of Pythagoras, whether you're in 2D or 3D, it's Pythagoras' theorem. So this is going to be the square root of 8t all squared, which is 64t squared, plus 18t squared all squared, 324t squared. So that's the speed. Now I'm going to differentiate the velocity to get the acceleration. And this I'm going to write as r double dot. R with two dots means we have differentiated twice with respect to time. So 8i plus 36tj. Same thing in part B, just slightly more complicated differentiation. So here's r. Let's differentiate once to get velocity, or you could write it as r dot. Then I'm going to find the speed. It's just 3D Pythagoras as above. We get an opportunity to do some simplifying here. I mean, I could have done a little bit of simplifying above with common factor of t squared. There'll also be a common factor of 64 and 324 as well. I chose not to. But in this one, when we find the speed from 3D Pythagoras, we get 36 sine squared 2t plus 36 cos squared 2t. And that's going to simplify a lot, because sine squared of an angle plus cos squared of the same angle is always equal to 1, regardless of the angle. So this fully simplifies down to root 40 or 2 root 10 if you want to simplify the third. So that's the speed. And finally, differentiate the velocity again to get the acceleration. And there we have acceleration. Note there's no k term here, because -2 is the coefficient of the k term, which differentiates to 0. So we don't need to write plus 0k, we can just leave it blank.